Will be the it not do my high school. So it's just a memory for me. Not the dog couldn't tell me to do. I didn't. Yeah, but it's just the only thing that I think is the impact or I think. Okay.
have 7:30. Today is just going to be a little bit of the first chapter, but it's not too much of real content yet. Okay. Just a little bit about me. So I'm Justin. Just call me Justin. Please do not call me Professor Justin, Professor Morris, Professor. Just call me Justin. Are we clear? It never works, so please. Even in email, I sign as Justin, so I prefer that. Okay. My office is just over here at VEP 6018, and the office hours are Wednesdays 12:30 to 2:30, I believe. It should be around that time. But if those times don't work for you, you can also email me for an appointment. We can meet through Zoom, something like that. But do just give me a little bit of heads up. If you try and email me like, I need to meet today for this question because homework is due today, then probably not going to meet. But if you give me a couple days ahead that you need to talk, then I can likely make time for you. Okay? Okay. So I am from San Diego. I went to Del Norte High School. It's technically part of North County, but it's really on the edge of the southern part of North County. And I did my bachelor's at UCSD and my PhD as a joint between UCSD and SDSU. So I just stayed in the same lab that I was working on during my bachelor's, and another advisor from SDSU. So my background is in computer engineering, so the cross between electrical engineering and computer science. So at that intersection is this course, computer architecture. And in terms of my research interests, I do research into lightweight machine learning and hardware acceleration, and then next generation computing or emerging computing technologies, which includes processing and memory. Right, so for teaching, I was a CSE tutor and TA and instructor for these different courses at UCSD. So 140L is digital logic. So it's kind of equivalent to 231, but 231 is digital logic plus assembly language here. So it's actually more close to EE 301, which I also teach here. And then 141 would be the class after that, which is computer architecture, which is this course, essentially. And then 142 is computer architecture as well, but at UCSD they have two choices. You can take computer architecture for like computer architects, which is 141, or computer architecture for software engineers, which is 142. And that's a different course that I developed at UCSD. We're thinking about bringing it here in the future, but for now we just have the 141. Computer architecture, computer architects. And then CSE 15L is introduction to different software tools and technologies. So things like GitHub and Jira, those kind of tools that really just start to learn at the beginning of your degree. And also like command line. Okay. So this semester, I'm teaching this course, so computer architecture. And then I mentioned before EE 301, which is the equivalent of 140, and that's digital logic. And I'm also teaching CE 100, which is introduction to computer engineering. So if you are interested in potentially switching to the computer engineering major, it's a course that you should take, because it is like the equivalent of CS 111 of the CE courses. So if that is something that you want to switch into, then you should take that soon. And we'll be offering it every quarter, every semester. So I'll be teaching it next semester as well. So this is a picture from about a year ago, a little bit over a year ago. And this is me and my wife. We were, I believe this was Alaska. Yes, Alaska. And then here's a picture of our three of our cats. We have since acquired 3 more cats. One was just acquired on Saturday. We found a cat. And no one has come forward as the owner of this cat. It was just in our parking lot. All right, so this cat, her name is Mi, and Mi is noodle or rice, depending on the language. And then this is kimchi. We all know what kimchi is, right? And nori. And we all know what nori is, right? And then Ninja, we didn't name Ninja. He was actually my friend's dog, but he had to move, and his new lease didn't allow for pets. So we acquired Ninja, and my dad had surgery last year, and he asked to have Ninja for his recovery time. We have not acquired Ninja back. He is now my dad's dog. And this is Taro. So of the ones that we did name, they're all food. And the other 2 cats are actually Mi's sisters. Again, one of our friends moved. Couldn't have pets. So we took 2 more cats. And like I mentioned, there's another orange cat that I just found in the parking lot on Saturday. So if you know anyone in the Mira Mesa area looking for an orange cat, I may have that orange cat.
No collar.
No color, no microchip. So there was nothing for us to distinguish for the cats other than post a picture on Lost and Found. Right. So this is actually false. You do not have a Zybook. So that is the old textbook, but we actually are using the same textbook that Zybooks was using, but now it's through the CSUSM library, so course reserves. If you sign into Canvas and click the course reserves, the library reserves tab, your textbook should pop up, and it's free for you to access. So no more paying for Zybooks $75. Okay? But we will still do Zybook style readings where after you read the assigned section in Canvas again, if you go to the quiz tab, you'll see a 3 to 5-ish question quiz about reading. And you have unlimited tries on this quiz. So it's just for your review. You should answer them all correct in the end because you do have unlimited tries. But I will encourage you to, when you do get a question wrong, go back to the reading, look it up. Don't just keep answering randomly until you figure out which one is the right answer. Okay. So grades will be uploaded to Canvas, and also all of the lecture slides and assignments are going to be uploaded to the Canvas, the Files tab. And what I will try to promise to do is have the lecture slides and the readings for the next week up before class on Friday. So that if you have a job or whatever, and you can't do the readings as they are due throughout the week, because the readings would be due before each lecture, you would be able to do all of the readings for the week during the weekend or something like that. And if you do not see them on Friday before class, on Friday during class, you can yell at me. and say, I need these, please get them up here by end of day Friday. Don't actually yell at me, but you know what, just remind me. Okay?
For sure.
All right, so we are going to use Gradescope. So I will upload your exams to Gradescope. You will upload your homework to Gradescope. And a couple things about Gradescope. So your homework is a fixed template. The space provided to answer, say, question 1, part A, is all the space that you are given. And you should use only that space. And you should not put question 1A on some different page than that. So I do provide the Word doc as well as the PDF. I used to only provide the PDF so that it's a fixed template, then you can't put things in different places, but students didn't like that. So I'm just telling you now, please keep it. If the question is on this page, keep it on that page. Okay? So the first couple of times, I'll let you resubmit and we'll be a little bit more lenient about this. But after the first or second homework, it'll just be like, not a 0, but like 50% if you're using the wrong format. Because the reason I need it as a fixed template is so that I can grade it faster to give you guys feedback faster. So if I don't have to go searching through your homework for your answer, it makes it easier. Okay. All right, so we are also going to use Piazza. So it seems that most of you guys don't use Piazza here. Is that correct? Not familiar. Okay, so I'm trying to change this. Piazza I find to be a much more feature-rich discussion board than Canvas itself. So do not message me on Canvas. If you have a private question or something like that, you can use email or a private post on Piazza. And if you have a question that you think that anyone can answer in the course, you can post anonymously if you want. You don't have to post anonymously. You can answer those questions anonymously or not anonymously. And you would be both anonymous to your classmates as well as me. So you have that option. You could be just anonymous to the classmates and you don't have to be anonymous to me, but you have the option of also being anonymous to me. And Piazza also makes it easy for me to reference like similar posts. Like if there's someone that had the same question, I can just easily reference and say, go look at this post. And you should all be enrolled in Piazza. Unless you enrolled in the class in the last like few days, then I would need to add you to Piazza. If you are not in Piazza, you just send me an email, your email, and I can add you to Piazza. You should also all be enrolled to Gradescope. Same thing, I use the class roster to import you all. So if you are not in Gradescope, I need to add you. And then you guys should be enrolled in Canvas automatically as soon as you enroll into the course. I can add you if you're not in Canvas for some reason, but usually that's not a problem. Okay? All right, so this is our rough calendar. We can change things as we go based on our pacing, but for this first 2 weeks, we're going to focus on chapter 1, which is computer abstraction and technologies. And then we're going to go into chapter 2, which is the MIPS instruction. And then chapter 3, computer arithmetic. And I think this is also from the chapters in the Zybook. Chapter 3 in the new textbook is actually not computer arithmetic, but performance. And then chapter 4 is computer arithmetic. Chapter 5 is single cycle, and chapter 6 is pipeline. But I know you guys will be looking back at this anyways. You'll just look at Canvas, the quiz. It says exactly what to read, And then your book is right there in the library reserve tab. So I'll fix this next time. And we have 1, 2, 3 exams. So exam 1 will cover chapters 1 through 3 of the new book. And then exam 2 will cover the single cycle and part of pipelining. And then exam 3 will cover the rest of pipelining plus memory hierarchy. And there is no final exam. Okay, so exam 3 will be during your final exam time. So you'll have the full 2 hours, but it will be designed exactly like exam 1 and 2 for 1 hour. But you can use the full 2 hours if you so desire. Okay.
Is the 2 hours split into 2 days?
Yeah.
No. So we come earlier?
No, you just come at the beginning, like a normal final exam.
Okay.
It's just that it will be a normal exam, 1 hour length, but you can use the full 2 hours if you want.
Oh.
Yeah, and they are cumulative in the sense that in order to understand pipelining, you need to understand single cycle and the performance equations from exam 1, but the questions themselves will be focused on the new content. Okay. All right. So lectures. So we are this place and time Monday, Wednesday, Friday. And attendance is required for participation. Participation is 10% of your grade. So we are going to be using Poll Everywhere to do peer instruction. And I also just use it as the way that I take attendance for that participation. And the purpose of lectures is to introduce the concepts through presentation and in-class examples through those Poll Everywhere questions. And you'll have a preview of what we're talking about in lecture 3 or 4. And I mentioned we'll use Poll Everywhere, and we'll set that up today and test it today. And you'll first answer your question on your own, and then you'll talk to people around you, resubmit the question based on your discussion. And we'll do an example of that today as well. And for lecture participation, it's just based on completion. You don't need to get the answer right to get the lecture participation. You just need to be here and participate. Okay? So grading. Homework is 20%. So your 3 exams are 45%. Weekly reading is 15%. And then the class participation is 10%. Last thing is this group presentation. This group presentation is going to be during the last week, so week 15, plus the first lecture, the last lecture on Friday of week 14. So you guys will be presenting during those times. You'll have 15 minutes. And we'll talk more about that later. But just for now, know that you will have a group presentation. It'll be about 3 to 4 people per group. So if you want to start talking and forming a group early, then you can do that, okay? Because you can make your own groups, and there'll just be a deadline of when you need to know what your group is, or else I'm just going to randomly assign who's left. Okay? So grading cutoffs, I'm using standard scale. So a 90 to a 93.33333 is an A minus. If you're at a 93.32, I'm sorry, it's an A minus. Do not ask me to round. There will be plenty of opportunity for extra credits, and I try and design the exams so that they are aligned with around 85% class average in terms of the final grade. So, and there are ways that I can adjust that from the exams. One of the ways I've done it in the past is offering exam corrections. So I've never had a really bad curve on these grades, so I don't expect to need to scale them. But if I do need to scale them, it will only go down. It won't go up. Like A minus won't suddenly become a 94, but an A minus can become an 89. Okay. But at the end, I've always only used the standard scale. I've never had to do any wonky grades. And then again, towards the end, please do not ask me to run. But if you do find an error, and that error would cause your grades to change, then of course do tell me. But if you find an error and say it changes your grade from a 91 to a 92, it doesn't change your grade, right? We don't need to discuss it. Okay? All right. So here is the poll everywhere question. And let me pull up poll everywhere. So your code is, so this is the link, pollue.com/JustinMorris540. This 3-digit code will change every day, but the rest of the link will not change. And if you just have the app, I believe what you would just put in is Justin Morris 540. But you don't need the app, you can just do it from your browser. But do make an account. And the one thing that you should do before you answer is there's a field for your name where you can put responding as. You should change that responding as name to your student ID. Because it is your student ID that I will use with my script to determine if you are here or not your name, because oftentimes your name does not match what your legal name is on Canvas, right? But your student ID will for sure match. So do change your responding as name to your student ID, and then answer this poll everywhere question. And then this is the question. Yeah.
Okay, the link again.
It's Justin Morris 540. Right now. Just to see if there are any examples there.
I'm looking at my here now.
So see this? This is the student ID. That is good. This is not a student ID. So if this is you, Boyd 083, I don't want your email handle part. I want your student ID. Same with David F. F010. Is this a student ID? This does not look like a student ID.
So for me, put student ID.
Yeah, there's a field responding as. Just change that to your student ID. So just change your name to student ID. And Jaden B, Dolfo S.
I think it's after you make your account.
How would you ready to have an account?
It's after you start the survey. There is a setting at the top where you can change responding as.
So you right here.
So first, start the survey. Click register. Join presentation. And then up in the top right, responding as. And then put your student ID.
Thank you. You just have to.
Yeah.
Walking anyway.
Did you?
Yeah.
Okay, so I have 29 people responding. I don't think that's quite everyone here. And again, this one is just practice. The first lecture participation I'm not counting. So it's not working. Okay, we will have another question, but it looks like all of you guys know this, right? So 96% of you are answering D. There are no labs for this course, right? So we have exams, we have the participation, which is this full everywhere. We have homework, and we have the group presentation, but no labs. Okay. Here is the more important full everywhere question. This is how we are going to do our peer instruction. So look at this question. I want you to answer this on your own first, okay? So do not talk to anyone, just your own opinion on these four items that you may think is a fact or not. Okay, did everyone have a chance to think about this? So now what you should do is talk to the people around you and see if their opinions can change your opinion about any of these statements, and then resubmit your new answer.
My name is Ben. Nice to meet you. So, how many of those did you want to do?
I mean, they all make sense.
We have the exact opposite. I said one of those only think cereal can be So, I would rather.
I can see an argument for any of them.
I see it as well. There can be.
Yeah, no, I mean, it's not a suit, but it could be. Like, what do you define as a suit?
Something that's more.
It's a suit.
So I would say cereal.
Yeah, I can see that. I can also see how they
Then like a casserole. Not really.
I can see the big argument. So in my case, I'll change my answer, but I'm gonna say all four of them.
I'm not a fan of the hot dog simply because hot dog is its own type of food and there's different types of hot dogs. We use different words.
Well, I bet too. I mean, at least it's ravioli and stuff.
I think it's funny. I think that's those layers.
So like for ravioli, is dumpling. What is dumpling?
I've never heard of it.
It's like a little like noodle, like
Why it's a dumpling.
When I think of dumplings, I think like our shells, like the puffs, right, and then the stuffing. And then I think, oh wait, it's like a ravioli.
Should we change our
Right?
answers?
It's like a real puff.
Right.
Inside meat.
Okay.
So, just like a different culture.
It's hard to change. It's hard to change somebody's mind.
I'll
But
take
that's true
that.
about the casserole thing, it's a little bit more. Because that is true, you just more
What
layers.
did I tell you, Paul?
I was.
What's my name?
Justin.
I'm telling you, it never works. So, yes, I'm your professor. Yeah. Huh? I'm 26. Yeah.
I'm probably the oldest one here, Justin. You're good. I'm 31.
I mean, it's normal for students. I think about 10% of our students are over there.
There you go. Just means I gotta drive to work really quickly after this.
Yeah.
when do you start work?
Technically,
Okay.
9.
So, I think that you guys are done discussing this, but you guys did have good discussions about this, yes?
Hope so.
I heard lots of noises coming from all of you guys, so that's what I want you guys to sound like when you're discussing the questions for our lectures. I don't want it to be quiet, I want you guys to be talking to each other, discussing, talking through how you got to your answer. So, anyone want to share what their opinion is on this?
I chose 0. And it should be that way. But I could be convinced otherwise.
I don't know, I mean, these are all opinions, so
Yeah.
it's pretty hard to change someone's opinion on these things.
I'm hard on cereal as a soup. That's the one that I'm ride or die on that one.
I just feel like, okay, so for ravioli being a dumpling is made out of like ricing, right? Some type of,
It's
it's
just
not
flour,
pasta.
flour and water.
I guess it is pasta then.
The only thing with like Asian dumplings, there's no egg.
Mm,
So the hydration is from just pure water, usually boiling water.
Then
So I guess cereal can be a soup then.
I guess. And then a sandwich, a hot dog is only one bun that, is folded, it's not 2 buns,
I think
So-
if
so it's like
it's
a
surrounded
sandwich.
by bread,
I think,
it's a sand.
I think a hot dog is more burrito than a sandwich.
It's not, no, it's not really, really
To be
big
a
about
burrito, I think you lost everyone. Now I'll get started with like the beginnings of chapter 1. You will read about this and we'll go over it again, like the later parts that we didn't cover today on Wednesday. But this first chapter is the Computer abstraction and technology. Let's go. First slide. So this is the chapter and the contents we're going to cover in this chapter. This slide, we are only going to be covering this introduction. So what is the computer revolution? Why study computer architecture? What are the layers of abstraction? And what are the components of a computer? Performance is chapter 2. So these were combined on the Zybook, but in our new textbook, they're separate. Okay. So you'll be reading about this bullet points for Wednesday. And I did post Wednesday and Friday, so you can read ahead to the Friday now if you want. And like I mentioned, I will try to post all of next week's before Friday lecture so that they're available for the weekend. Okay, so the computer revolution. So computers, they have been evolving very, very quickly, right? The progress has been very steep. They've only been around for like 40, 50 years, real computer, like consumer grade computers. And we've gone from a computer being the size of a room to the size of a desk, and now they are phones, right? In your pockets. And we've also grown the connection between computers with the internet. Is it good? Is it bad? That's another debate that we can have.
310.
And then we have very powerful search engines. And beyond powerful search engines, we are now having things like ChatGPT, right? And we're trying to evolve into more autonomous vehicles with smart cars. And we were also able to now sequence the human genome. We were not previously able to do this. And the computing field is still evolving very quickly. So even though the Moore's law has ended, we are finding new and innovative ways to find performance still. So that goes back to how I was talking about my research with emerging computing technologies, and one of those being processing. So that's how we're kind of fighting this end of Moore's law. So we can't just pack more transistors. The processors. General purpose computing is kind of at a standstill, but accelerators and domain-specific computing is still improving quite a lot. So computing. So we know personal computers, right? So this is what you use all the time, pretty much almost every day, right? And they have a display for graphics, and you have user inputs with your keyboard and mouse. And it's relatively decent performance to single user at a low cost. And then there's servers. So servers, they have greater computing power, lots of storage, like you have Google Drive or Microsoft OneDrive, right? It's just a storage platform, right? And because they're serving billions of users, they have great input and output capacity compared to your personal computer. And there is also a larger emphasis on dependability. So often the data is duplicated in multiple different locations as backups because it relies heavily on being that service for you. So if your photos of your precious cats just disappeared, you would not be using that service anymore, right? And so there are low-end servers that run larger programs for multiple users or just file storage. And then there are high-end servers, which would be running things like ChatGPT. Okay? And then there's also embedded computers. So usually people know personal computers and servers, but embedded computers are kind of hidden from you, right? You don't really think of a car as a computer, but it does have a computer in it, right? And then also things like plane will have a computer for navigation and all of the sensors, things like that. Your TV most likely has a computer in it nowadays. And these are usually targeting minimum performance with a limitation on the cost and the power. And the cost is to limit how much it costs to produce that device and increase your profits. And then the power limitation comes from usually it's running on a battery. Like your phone will have a battery, so you have to have power limitations. So in the post-PC era, we are seeing these different classes of computing transform. So your personal computers are quickly becoming more mobile. Like lots of people no longer have the family desktop computer, right? Everyone's having their own laptop. Some people don't even have laptops anymore. Then maybe they're switching to just tablets or even just their phone. And then servers are moving more and more towards computing as a service. So lots of people might not even download Microsoft Word or Office, right? You guys might just be using it through the browser, kind of like you used Google Docs, right? Yeah, and also there's very large providers like AWS or different services like Netflix posts almost all of their content on AWS. So that's why when you see AWS go down, like more than half the internet goes down, right? So why study computer architecture? So as a computer scientist, you will need to develop high performance programs on any of these different platforms, right? From the personal computer to servers to embedded systems. So if you know more about the underlying architecture in these different systems and how they are different, you can better optimize your program for those target applications. You might also be designing system software, so at the compiler or operating system level for a new processor, and having more information and knowledge about the processor will help you design, again, better algorithms that are more efficient, faster, use less power. And then the other thing that you might want to be able to do is be able to evaluate different computers so you can choose the right computer for a given application. So if you know that this algorithm works well with these processors for this reason, maybe it has a larger cache or whatever the reason is, you can make more informed decisions if you're making a large decision, like for a company, we need to upgrade our servers in order to make our application better so that we can attract more users and differentiate ourselves from competition. Okay? And also to understand these things, you should understand benchmarks. So the one thing that I hope that you would take from this course, if you don't take anything else, is the knowledge towards the end, especially with caching, on how to write better code for processors. So you can get upwards of 100 times better performance just by rewriting code for the same algorithm in a slightly different way sometimes. Okay. So what is computer architecture? Well, computer architecture explores how machines are designed, built, and operate. So we're going to go into the details of how exactly each instruction is executed in a processor. We are going to be covering subsets of the MIPS instruction set architecture, and we are going to be showing a very basic overview of a CPU architecture, but the same principles that we cover would help you learn more advanced architectures if you are going to continue in this path of computer architecture. Right, and again, knowing what's inside and how it works will help you to develop your applications better, faster, cheaper, and more efficient. So you'll be making more informed decisions rather than, I'm going to change the algorithm this way, let's see if it works. You should be saying, I'm going to be changing the algorithm to do this because of this aspect of the processor or something like that. And this will also allow you to appreciate the relative costs of operations and the effect of different programming choices. Right. So what we will learn, so how programs are translated into a machine language and how the hardware executes them. The hardware-software interface, so how software instructions and hardware are going to perform those needed functions. And then again, we're going to talk about performance and then how these different factors are going to be affected. How can we improve these different components of the performance equation to get better performance? And then we'll talk about both how a programmer can improve performance as well as the computer architects or hardware designers can improve performance. So we'll be looking at it from both perspectives. All right. So to understand performance is going to depend on a number of things, right? So from the programmer's perspective, your algorithm will change your performance, right? So we have learned big O notation, right? So that would be your algorithm. Are you picking the best algorithm that has the best average execution time? The other thing that will affect your performance is just the programming language, the compiler, and the architecture that you're targeting, right? So if you're targeting like a Raspberry Pi, its architecture is very low power, right? It's not going to have as feature-rich instructions as something like your laptop. So you're going to have lower performance usually on something like that. And the Raspberry Pi would be very similar to like a phone too, right? And then the processor and memory system, it goes back to the same like example of a Raspberry Pi, right? So its processor is slower, it's less instructions, you might have worse performance on that. And maybe your application is so simple that the difference in the processor makes no difference. Okay? So maybe you can save a lot of money by buying these smaller processors and buying many of them than buying like large server grade Xenons from Intel. And then the other thing that you should consider is my application going to be very heavily input-output oriented, or is it more compute-oriented? So that is where I want to stop for today. So at the end of each lecture, I will have this reminder that you do have a reading due before the next class, but do not get ready to go yet. I do just want to look at the survey results again to make sure that we are all answering with our student IDs. All right. So David F., you need to change responding as. NF010. If you are confused about this, do ask the people around you, because as you can see, many people did figure it out. We did know how to do it.
Responding with the student number here, does it add an extra student if I change the name?
No, it would change you maybe. It should change you. But again, this one is practice. So if you changed it there, let's look at it again in lecture 2. And I'll run my script like every Friday. So we'll figure out if something's wrong, and I'll tell you if something's wrong. But if you see your name up here, that's just an indication of maybe just check it right now to double check. Right, so Alan M, Rachel S, JB.
Actually changed it for question 2.
So Riley S, Dean L, Kanto U, Leslie C. Do double check. And we'll see if everything is fixed for. So it's on campus. I'll just open it up again. You want to take a picture? Alright, see you.
Are you in the one class? Yeah. Right. So you're gonna be staying right here?
Yeah, I got a physics class.